Hello students, welcome to EPG Pathshala. I am Dr. Anupama, Professor at Department of Economics, Punjabi University, Patiala. I am here talking on behalf of Dr. Falendra Kumar Sudan, Professor, Department of Economics, University of Jammu. I am going to talk about the module Population, Consumption and Carbon Emissions from Demography of Climate Adaptation. So students, we are going to discuss about the change in composition of population, their changing patterns of consumption due to economic growth, and hence its impact on carbon emissions. Each year sets a new record in terms of the global temperature rise. This is particularly peculiar on two fronts. First, the increase in the quantum of greenhouse gases, and second, the annual increase in the global population. What is even more interesting is that the linkage between these two has seldom been extensively discussed. If the population policies have a sound logic and implementation conviction, they can be quite helpful in slowing down the rate of climate change. Global community is making efforts to shift from a regime of carbon-based fuel usage to a carbon-free one. But this transition could be possible if the global population rate reaches its replenishment rate. Today, the most rapid population growth tends to occur in countries where per capita greenhouse emissions are relatively low. Yet, economic development is likely to boost these nations' per capita emissions at a time when their total populations will be much higher than the current levels. So with this background, this module aims to discuss the per capita carbon dioxide emissions derived from the fossil fuel combustion and cement production, to chart out the graphical profile of countries with million plus population by per capita emissions, and to trace the global emission trends. The future rate of population growth would actually depend to a large extent upon the government's current population policies. The country-wise data sets on annual emissions of carbon dioxides from the combustion of fossil fuels and the manufacture of cement and the annual population growth could prove very useful in terms of the strategy required to slow down the rate of human-induced climate change. During last 6 decades, the world's population grew from 2.5 billion to 5.7 billion. If the current population growth rate continues, then by 2040, world population would increase by a further 2.1 billion to 4.4 billion. The ongoing population has greatly influenced the Earth's atmosphere in the late 20th century. The continuing rate will ensure that the effect on Earth's climate and atmosphere is lasting and not a temporary one. There is a wide disparity when it comes to the usage of global atmosphere and leaving the carbon footprint. These disparities in global emissions have proved to be the biggest obstacle in global efforts towards managing the atmospheric purity. The developed world is responsible for highest per capita global emissions, even with a low population growth rate. The population of developing world is expanding at an exorbitant pace, but has a lower per capita emission contribution. As such, none actually owns the responsibility towards the climate change. But there could be very little doubt that per capita emissions and populations are increasing rapidly. The industrialized world saw increases in carbon emissions and population growth many decades ago. The same phenomena can be seen in the developing world today. The population in developing countries has been increasing quite rapidly. The rapid economic growth has increased the carbon emission levels tremendously in a short span of time. The global community needs to understand the atmosphere and the resources of the earth are common property. It does not matter who is causing more emissions because the atmospheric degradation actually doesn't recognize international borders. The biosphere and the Earth's atmosphere have a limited replenishment capacity. The global emissions are fairly unequally distributed. The appropriate strategy would be to focus on lowering the individual emission rates. This could be achieved by a flexible emission transferable mechanism via which the greater emitting nations could compensate the lesser emitting countries. This would encourage global emission reduction rates. At the same time, it also becomes imperative that the population growth rate must be reduced. Carbon dioxide emission trends. The carbon dioxide emission tops the list of the greenhouse gases. Other gases such as methane, which are more effective in trapping heat, their concentration in the atmosphere is quite low. The carbon dioxide becomes the most potent heat-trapping gas due to its concentration and emission rate. The carbon dioxide emissions have their origin in the combustion of fossil fuels and cement production. The combustion of fossil fuels is one of the chief culprits in increasing carbon dioxide in the air. Global emissions of carbon dioxide from fossil fuels and cement production rose significantly in recent past. Alongside, the population has also increased more rapidly. Although carbon dioxide accounts for nearly half of such emissions, the other greenhouse gases such as nitrous oxide and methane are also dispersed into the atmosphere due to such combustion. The destruction of world's forests and the changing land pattern is also contributing much to the carbon dioxide emission level. This is widely seen in case of the developing world. The use of biomass and fuel wood, along with environmental and soil degradation in these countries, are chief reasons for increasing carbon dioxide concentration in the atmosphere. Together, these add an estimated 0.6 to 2.6 billion metric tons of carbon to the atmosphere each year, compared to about 6 billion metric tons contributed by the use of fossil fuel and cement. Population growth and emission equity. If we dig deeper into the global per capita emission figures, it will reflect huge disparities in per capita emissions by country. The average person in the United States contributed more carbon to the atmosphere, more than 16,000 times contributed by an average Somali. 1/5 of the world's population is living in countries with the highest per capita emissions and contributed 2/3 of the world's fossil fuel carbon dioxide emissions. This group belongs to the category of high emitters. The other 20% of world population, just 2% of global carbon dioxide emissions, and these belong to the category of low emitters. This category actually belongs to the world's poorest 1.2 billion people who survive at roughly just $1 per day. The largest proportion, which comprises of 60% of world population, comes under the category of middle emitters. This group usually comprises of the thriving middle class of 3.6 billion. The concept of national emission has been developed by 1997 Kyoto Protocol to the Framework Convention on Climate Change, under which the developed countries had to ratify the binding commitment of curbing their emissions of 6 greenhouse gases, including carbon dioxide, by a total of 5.2% from their 1990 emissions, whereas the developing countries faced no such obligation. This criterion faced serious criticism from the developed world, mainly the US. The reason is that the concept of national emission comprises of the total of those emissions that occurred within a nation's borders. By this definition, China is a major contributor to climate change, despite the fact that 7 persons in China contribute less fossil fuel-based carbon dioxide than one American. Using the same criterion, among other populous nations, 24 Nigerians contribute the same amount as an American. In the most extreme examples, hundreds of people in Burundi, Chad, and Somalia burned less fossil fuel than the average American. Therefore, the argument put forward by the developed world that it is fast-growing developing world that should be taking the initiative of carbon reduction lacks a sound logic. With the economic development moving from the localized industrial regions of the developed world to the developing parts of the world, the emission gap has been reduced since the 1950s. The high emitter group, which comprised of around 20% of the world population, contributed around 80% of the global emissions in 1950. Now, this percentage came down to below 66%. The low emitter group used less than 1% of the global total of fossil fuel consumed in recent past. This reflects that although per capita emissions have been reducing, the national emission rates have increased. The growing population makes a situation more worrisome. The rising population will make it more difficult for technological improvements, economic adjustments, and lifestyle changes to slow the pace of economic change. If the world decides to cut the global emission rates by half while the population doubles during the same period, it would mean that each person will have scope of emitting just 1/4 of greenhouse gases than what he is emitting currently. But not everything is lost. World population trends in the present times give a ray of hope. It seems that the nations across the globe are concentrating not just on rapid economic growth, but economic development. This means strategy aimed at providing better health, education, and financial facilities to the people. Women empowerment, family planning, and childcare becomes essential features. The focus has to be on the quality rather than the quality of rather than the quantity of service provision and accessibility. If the family patterns continue to change for the better and if governments act today to make reproductive health care widely available and to improve educational and economic prospects for women, world population may decrease modestly in near future. Unless this happens, it would become mighty difficult for the world to bring global greenhouse gas emissions to low levels to avoid rapid and possibly catastrophic climate change, while ensuring rapid economic growth and human development. Let us discuss about the population and Kyoto Protocol. The diplomats who sat together to frame the Kyoto Protocol actually overlooked a few of the essential points. One being that the developing world, with its rapid rate of population growth, was kept outside of its ambit. Other being that the binding obligations which were put on the developed world were not so stringent and hence less effective. The carbon trading, as allowed in the protocol, might reduce the direct need of emission reduction, but it will increase the cost, causing inclusion of negative externalities. In any case, emission reduction seems to be the best alternative. The European countries with lesser population growth rates have an advantage in this regard. Technological advances and modest shifts of fuel type, for example, from coal and oil to natural gas, are more likely to enable these countries to come under the Kyoto limits, simply because they are experiencing much slower population growth than the US. Like the US, other developed countries like Canada have agreed at Kyoto to decrease emissions significantly despite ongoing population growth of roughly 1% a year. Australia, with similar population growth rate, has negotiated increases in its allowable greenhouse gas emissions by putting forth the argument that its growth is actually dependent on emissions producing activities. How much a particular country will contribute to the global emission levels will actually depend on the future domestic population projections. But the population dynamics in the whole spectrum of emission levels has been largely left untouched. Population and global emissions. With the great disparity among the nations of the world when it comes to the emission levels, none of the countries is actually eager to come up with the initiative. Actually, none wants to bear the responsibility and the associated short-term costs. Thus, many nations have already started to look for alternatives beyond the Kyoto. The long-term emission reduction will require global participation and a transition towards renewable resources of energy and cleaner fuel technology. This is very much possible using a gradual process. The international institutions can be developed which can ensure that every country sticks to its emission limits and, on other instances, compensate the rest of the countries for any breach in the specified limits. But here lies the issue of population dynamics. A rapidly growing population can halt any progress in emission reduction. the human-induced climate change is alarming. The population growth is considered as the biggest culprit of global emissions and accounts for about one-third of world emissions. At the same time, the developed world, with its lower population, accounts for a massive emission contribution. The basic logic behind this fact is that during the phase of high population growth, the emission levels are less, and once the country becomes developed, the population growth rate reduces while the per capita emission rate increases. The same phenomena can be seen happening with developing world, where the population growth has slowed down and the per capita emission levels are on a rise. The conventional analysis tend to miss this critical linkage of population and climate change. Population and per capita emissions. The population emission dynamics can also be described using the concept of stabilization of emission of greenhouse gases. This can be very well analyzed using the logic of equal access. The principle of equal access can be distinguished from the concept of per capita emissions convergence. The convergence is actually a hypothetical equalization of the per capita emissions of all nations, which few economists believe will ever occur. By equal access, one means that everyone has the right to use the Earth's resources and atmosphere and has the equal right in emitting the carbon emissions into the atmosphere. This access has to be non-conflicting, meaning that it should not hamper others' access of the same nature. This principle clearly indicates that those countries which are over-accessing their rights and breaching into the access field of the low-emitting nations must own the responsibility and take necessary steps to tackle the situation. One of the ways is to reduce the emission rates altogether. The other way could be to compensate the low-emitting countries for this over-access. The compensation could be financial as well as technological. Still, another way could be to contribute to the Global Green Fund, which is managed to ensure investment in cleaner fuel technology and sustainable structures. The carbon emission trading, as mentioned in the Kyoto Protocol, is based on the similar logic. This way, the negative externalities generated by the carbon emissions and greenhouse gases could be internalized. Now, such an alternative seems very attractive theoretically, but practically, no democratically elected government would want to put its citizens on a binding emission quota. But the principle does simply imply that over-emitters will be required in some fashion to compensate the under-emitters, with both the level and perhaps the cost of over-emissions set by international agreement. But again, the population dynamics will play its part. Any emission reduction strategy has to be complemented by family planning services, better livelihoods, women empowerment, and of course, education. In stabilizing the atmosphere, the equal access principle was illustrated by the concept of per capita atmosphere stabilizing emission of carbon dioxide from fossil fuel combustion and cement production. The Intergovernmental Panel on Climate Change, that is IPCC, suggested that at least a 60% reduction in carbon dioxide emissions from 1990 levels would be needed to stabilize carbon dioxide concentrations at their 1990 level of 353 parts per million by volume. Given 1990 global emissions of 6.1 billion metric tons of carbon in the form of carbon dioxide derived from fossil fuel and cement, the atmosphere stabilizing global emissions in this category would have been 2.44 billion tons. Divided among the world's 1990 level population, the per capita atmosphere stabilizing emission would have been 0.46 tons of carbon or 1.69 tons of carbon dioxide. This figure is less than 1/10 of the 1995 US per capita carbon dioxide emissions of 5.3 metric tons of carbon. It is roughly equivalent to burning enough gasoline to drive a typical van, pickup truck, or sports utility vehicle. This per capita atmosphere stabilizing emission level could be seen as the dividing line between nations, or for that matter, between individuals, effectively contributing to climate change and those making no contribution. The Middle Eastern oil exporting states with relatively small populations remain at the top of the list, probably due to their intensive oil processing activities and general economic dependence on petroleum. US trails these countries but leads the rest of the world in per capita emissions. With about 5% of the world's population, the United States produced more than 25% of global fossil fuel carbon dioxide emissions. At the bottom of the ranking are placed some of the least developed low-income countries of the world such as Burundi, Nepal, Laos, Cambodia, and Haiti. If the goal is to stabilize atmospheric carbon dioxide at 1990 levels, the benchmark of the per capita atmosphere stabilizing emission would vary from 0.09 tons of carbon in the year 2150 under the UN high projection of population growth to 0.69 tons of carbon under the low population projection. The latter figure is higher than the stabilizing emissions stood in 1995, meaning there would be more scope in the atmosphere for each person to release carbon dioxide than today. This is the simple result of having fewer people on the planet in 2150. Under the UN's low fertility scenario than today. Future population will determine the level of carbon dioxide emission that is both equitable and climate safe. So students, let us sum up what we have learned from this module. The world will have a clearer picture of the global emission rates and the population growth rate by second half of the 21st century. It will be much clearer whether the human population reaches its peak and tapers off, or whether the population surpasses the 12 billion mark. It would also become clear as to whether the emission rates have been curbed or whether they have moved unchecked and reached catastrophic levels. Over the next decade or so, however, the path of human population and to a lesser extent that of greenhouse gas emissions is fairly well established. So much momentum is built into the global economy and into the age structure of population that significant growth in global emissions and human numbers seems inevitable. This is an alarming situation but brings complacency. The obvious argument would be why to do anything now and when we know that whatever effort we might put in would only be futile. But this is a misplaced argument. Only by taking the necessary steps today can governments hope to bring the graph of global emissions and population rates down. There has to be a transition towards efficient fuel resources and renewable resources of energy. Investment in energy conservation and cleaner fuel technologies become imperative. On the other hand, greater focus should be on family planning, women empowerment, and education of the masses. None of the two strategies could prove successful alone. Both of these need to be complementing each other. The dual action of these policies could very well ensure that both population and emissions trends will stop their growth and reverse course before the middle of the next century. That's all with this lecture. I hope you must have enjoyed it. Thank you.